7th graders, if you're watching this, you guys are obviously absent and you guys will be completing 1.2 Evolutionary History today. This is our first lesson in this new unit, which is also fairly new to me. Okay, your learning target for today, I can identify similarities in body structure. So really in this first chapter, we're really going to dig into how we can compare structures of different organisms throughout time to kind of determine different relationships. You know, is one a common ancestor, or was one a descendant species, and our descendant species related to each other based on this common ancestor. So that's going to be really the essence of all of chapter 1. And then in chapter 2, we'll start looking at differences. Okay, so just to move on, your learning target today, I can identify similarities in body structures of organisms. Okay, as this is our first lesson in this new unit, you guys will need to set up your notebook. So you'll go ahead, go into OneNote today. You guys will add a new section, title it Evolutionary History, and then you guys will need to add 1 page, and now you'll have 2, Title 1 vocab, Title 1 key concepts, and then today you guys are going to add the unit question. Why do species, both living and extinct, share similarities and also have differences? Okay, so that's, you guys can see my unit question added right there on the key concept. And you guys have some vocab to add as well. You're going to add a paleontologist, which is a scientist who studies fossils in order to understand the ancient history of life on Earth. Okay, you're also going to add species, which should be fairly familiar to you guys, is a group of organisms of the same kind in one or more populations that do not reproduce with organisms from any other group. Okay, and then finally, body structure is a part of an organism, for example, one or more bones. So obviously we're going to be looking at a lot of old organisms where all we have left of these organisms is the fossil record. Okay, so we're going to be focusing a lot on bones, but it's not just limited to bones when we talk about body structures. Okay, it's just what we can work with best with organisms that are no longer around. Okay, so again, you guys should have added those 3 vocab words, paleontologist, species, and body structure to your vocab. You guys can see there's a lot of vocab in this unit. Okay, all right, moving on. You guys have a warm-up for today. You guys can see, all right, you got a little paleontologist out here digging. They've unearthed some fossils. So they're looking at those fossils. Okay, and what we're going to find in this is what we call a mystery fossil. And throughout this whole unit, you guys will be trying to place the mystery fossil and figure out which it's more closely related to. Okay, your 3 options that you'll learn will be crocodiles, wolves, or whales. Okay, so this is a diagram of what your mystery fossil looks like. Below is a drawing of a fossil that is millions of years old. This fossil was just taken out of the ground and no one knows what kind of organism it is. One way scientists identify a fossil of an animal with bones is to compare the bones of the fossil to the bones of other organisms, which you guys kind of became familiar with when you guys did the Great Fossil Find recently. So you guys were able to kind of look at some skeletons of other organisms that you know and kind of compare what's similar and what's different. Okay, so your question for that warm-up, do any of the fossil's bones look like bones from other animals? Describe your thinking. So take a look at what you guys see. What do you guys notice about it that might be something that you are familiar with? Okay, so answer that question there. Okay, when you guys are done, you guys can go ahead, pause this video as you need, and move on to activity 3. Okay, on activity 3, you guys have a little video to watch. So you guys will right-click and open up this video. You guys will get this little video pop up here. It's about 3 minutes long. So you guys are going to learn about how we're going to be placing this mystery fossil. Okay, so go ahead, again, pause this video, take about 3 minutes to watch this video, and then we'll move on to the next part. All right, so the next part is going to be a little card sort. Obviously, those who are doing this assignment in class will actually have the physical cards with them, but because you guys are working from home or working on a different time frame, you guys will be doing this with the next slides, I think through slide 18. Okay, so I've taken all the cards and just screenshotted them and put them on these slides for you guys. So these are slides we won't use in class, but you guys at home will be using. Okay, so how this is going to look is you guys are going to take a look at the cards and you guys are going to try to make groupings of 3. There's 9 cards total, so obviously you guys will make 3 groups of 3, and in these 3 groups of 3, you're going to kind of determine which you guys think are more closely related. So on one side of the card, you guys will read a little description. So this is one possible grouping that you guys could look at, and you guys can decide that, yeah, this is the correct grouping. or once you guys kind of read about the other organisms, you know, maybe this isn't the right grouping and I want to switch it up a little bit. But the 3 animals that they put in this is a camel. Camels are plant-eating animals that live in Africa and the Middle East. They walk on 4 legs on land and can store fat in their humps. They can walk long distances, often in hot, sandy environments that can make it difficult to walk. Their legs are strong. Okay, another organism, which obviously is no longer around anymore, is a Titanotylopus. Titanotylopus. This plant-eating animal was a type of giant camel, so obviously it's got some relation to camel, so I would go ahead and wager that it's probably pretty closely related to a camel, but it was 3.5 meters tall, so it was much bigger than a camel. The oldest fossil is about 10 million years old. Titanotylopus was extinct about 300,000 years ago. It walked on 4 legs on land and could store fat in its hump. Titanotylopus often had to walk long distances in search of food. Its environment varied but could include rocks, mountains, and flat grassy areas. This animal's feet were a lot like the feet of the camels that are alive today. And then finally the Pachycetus. Paleontologists believe that this small animal lived on land but hunted in swampy waters. So there's a big difference there. It had long legs considering that its size was pretty small. It was only about 1 meter to 2 meters long. Pachycetus had a small, narrow jaw with teeth that were good for eating meat, both land animals and fish. The oldest fossil is about 50 million years old. They went extinct about 34 million years ago. So you guys can kind of see how much older this is than a Titanotylopus and a camel. Okay, so there's 3 organisms that they suggested as a grouping, but as you guys read through this, you guys will want to make your own conclusions. Okay, if you flip over the cards, which I've also included on these slides, you guys will see a skeletal structure. So you guys will be able to see, all right, this orange one right here shows the placement of its nostril. You guys can see the pelvic bone, the radius, and the ulna were all 1 bone in this case, whereas human beings have 2 bones. Okay, we have a radius and an ulna. So if you guys feel your arm, you guys kind of squeeze that and rotate your hand, you guys will feel 1 bone on one side and another bone on the other. Okay, the ulna is what connects to your elbow. So if you guys run your elbow up, that's your ulna. And then the one on the opposite side is going to be your radius. Okay, so you guys can see how kind of a camel is different than a human. It also shows you guys this little soccer ball, so you guys can kind of see the difference in sizes. Okay, so here's the soccer ball. Here's how big a camel is compared to that soccer ball. And then you guys will be able to compare the size for maybe the Pachycetus or whatever the case. Okay, and then you guys can see all the other bones there. Okay, so read the species cards. Obviously, you're at home working this by yourself, so you're going to do this on your own. Carefully examine each species card. Consider the titles and labels on each card. Pay close attention to what each species shares with other species. Discuss with your partner how to group the organisms. So you guys will obviously use both the front size, that's just like a description of the animal, but also use the size and the skeletal structure on the back to help you. Use the information you learned as you read the cards. Decide on at least 2 groups you can put each organism into. The group should be based on ways that the organism are similar to each other. Sort the cards into groups. Be prepared to explain to other students why you sorted the organisms the way you did. Okay, so if we take a look, these are the other organisms. I'm just going to blow through really quick. So great white shark, you guys can read about the great white shark. You can see its comparison from a skeletal to the soccer ball. Eusthenopteron. You guys, it's kind of like a fish, so you guys can kind of check out what that looks like. Here's your guys' little Titanotylopus, which we just talked about. Here's the camel. Again, you guys can see how much bigger this Titanotylopus is compared to the camel. If you guys look at the little soccer balls. Okay, Meganeura, which is obviously similar to an insect. Okay, Ammonite. So you guys can kind of see what that looks like. Obviously, we don't have just like a skeletal structure of that, because when we learn about organisms like this is they don't actually have a skeletal system internally. Their skeletal system or their body is protected by a shell. So this is all that's kind of left of them to look at. Okay, fruit bat. You guys can see what a fruit bat looks like. And a dire wolf. Dire wolf is an ancestor of the wolves we see today, much larger than what you guys would see roaming around like Yellowstone. Okay, so you guys will read through all of those. And again, you guys are going to do your groupings. If you think that the original grouping they did with the Titanotylopus, the camel, and the Pachycetus were good, you guys will click and drag those into one grouping. So each of those boxes kind of represent a grouping. Okay, so if you guys think that at the end of the day, yes, those were the best for that group, you guys go ahead and drag them there. And then try to go ahead and drag and make 2 other groups based on what you guys see in those cards. Okay, so go ahead, take a second, pause that, and then we'll move on to the next part. So go ahead and do that card sort through slide 19. All right, after you guys have completed slide 19 in your card sort, you guys are gonna take a look at this little message from the museum where we're trying to sort our mystery fossil. So we want to make sure to place a mystery fossil in the museum with a group of other species that it makes the most sense for the fossils to be with. To make this decision, you will need to do the work of making careful observations and spending time comparing the bones of the mystery fossil to the bones and body structures of other organisms. We asked our intern paleontologists at the museum to quickly examine the mystery fossil bones and give us some initial ideas about what species in the museum the mystery fossil might be most similar to. Their first examinations of the mystery fossil tells us that there are 3 main types of organisms that the mystery fossil could be grouped with. So we're either looking at whales, wolves, or crocodiles. Okay, so here are our 3 claims. Where in the museum does this new fossil belong? Claim 1, the mystery fossil belongs with the whales in the whale cetacea exhibit. Claim 2, the mystery fossil belongs with the wolves in the carnivore or carnivora exhibit. And claim 3, the mystery fossil belongs with the crocodiles in the reptile or reptilia exhibit. Okay, so throughout this unit, you guys will be kind of narrowing down and eliminating, all right, we don't think it goes here, we think it for sure goes here. But that's kind of where we're looking at for the rest of this unit is where can we put this mystery fossil. Okay, so let's take a look at how we might do some observations and what a good observation would look like. So activity 5 is comparing body structures. So if we look at this observation and say, all right, this organism has legs, okay? And then we were to look at 2 fossils here, okay? Is this a good observation? Because can I answer this question? Which organism is observation 1 about? Okay, based on observation 1, it has legs. Which organism am I talking about? Okay, you don't know because they both have legs. So is that a good observation to make when we're comparing body structures? Okay, let's take a look at a second example. So this is observation 2. It has 4 legs, each leg at least 2 long bones in it. Compared to a soccer ball, the legs seem to be about the same length as 6 to 8 soccer balls on top one another. Okay, so there's a good observation, much better than the first one that says it has legs. So if we were to look at this and say, all right, it has 4 legs, so all these have 4 legs, so obviously we got to go a little bit further. Each leg has at least 2 long bones in it. So if we kind of zoom in on this one's hard to see. It looks like there's 2 long bones. Really, I only see about 1 long bone in its legs. Okay, this one has 2 though. Okay, and each of the long bones or each of the legs seem to be at least the length of 6 to 8 soccer balls. So if we're looking at this guy, we're only got maybe 1, 2, maybe 3 soccer balls. This one definitely has more, 1, 2, 3, 4, 5, 6-ish. Okay, so definitely looking, and this one's back are a little bit longer because they go up to the hip. So we're obviously looking at the Titanotylopus here. Okay, so when we're making observations, these are some guidelines I want you guys to follow. So pay careful attention to body structures, especially how bones are grouped together. So observe the size, the thickness, and the length of bones within many body structures. Observe the position of the body structures. So where do we find them at? Are they tipped? Are they flat? Those kinds of things. Observe the same fossil evidence several times to see what you missed. So you really want to go back and forth and really look closely. Okay, you can also count the number of bones. So if we're talking about these distal bones or the bones in the hands or the feet, okay, how many are there? Because that's huge too. Okay, and then use observations of fossil evidence to make careful comparisons to other fossils and living species. Okay, so we'll be taking stuff that we know, living species, and comparing them. So if we look at this, okay, we're comparing 2 of the organisms from the card. Okay, this is the Eusthenopteron, okay, and the Titanotylopus. Okay, we see that they have a little pelvic bone here, and then their pelvic bone is here. Okay, but are they the same? Okay, this one's attached to the backbone. This one's kind of free floating and attached to one of the fins. We also see, if you guys, again, it's kind of hard to see, but if we were to zoom on that, you guys can see a little pink bone in here, which would be similar to this pink bone, a green bone, and we got little blue bones, but are they the same numbers? Okay, so you can compare. Obviously, these are way smaller. Again, they're not attached to the rest of the skeletal system. The grouping's way different. These two are oriented back into the fin, whereas this one is more of a limb or a leg. So you guys can really think about those things when we can compare. Okay. Moving on to your final activity is a little reading. So you guys go ahead, right click that link there, and you guys will pull up the cat that wasn't a cat at all. And you guys are going to learn about a fossil that was uncovered and it was mistaken for an organism that was similar to a cat. But you guys will find out what it actually was and how they were able to use similar body structures or shared body structures to determine that. Okay, so go ahead, read that article, and then answer these two questions. The first scientist misidentified the fossil as that of a big cat. What body structure did he use to make his observations? And what body structure did the second scientist use to determine that the first scientist had misidentified the fossil? So what did the second scientist do that kind of corrected the first scientist? Okay, once you guys are done with that, go ahead, do your wrap up. Any questions, circle yes or no. If you guys have any questions, type them right there, and then circle 5, 4, 3, 2. How do you think you did? And you are all done. Great work. Go ahead and hand this in, and I hope you guys are having a great day. Thanks.